Thank you, everybody, for coming. So we're going to be talking about migrating thousands and thousands of VMs from VMware to CloudStack. Last year, we were planning it, and this year, we have done it. We have developed tooling that is entirely open source and relying on open source to enable people to move away from VMware, and that number there is, sounds high, but actually we are well past that number now as I talk in terms of VMs that our customers have moved from VMware and onto CloudStack. And when I say CloudStack, I mean CloudStack KVM. So my name is Lucian. I'm a long-time member of the Apache CloudStack project, and my background is system administration, operations, data center operations, and I'm also a cloud architect at ShapeBlue. So we start with a very short story. It was May 2022. And these kind of people were trying to come to an agreement on how to basically buy VMware. And those guys are Broadcom. And of course, 1 year later, in 2023, in November actually, so almost to our date, 2 years ago, VMware were joining the likes of Symantec, Brocade, LSI, great products with a great history and unfortunately not great future. I hope VMware's not going to follow exactly in their footsteps, but the trend is there. So you can see here, that's the ShapeBlue Cloud Architecture department, where we were looking at the show and getting ready to get overwhelmed from all the deluge of people trying to migrate away from VMware. And indeed, in many ways, it's what happened. Of course, we didn't have to deal with ugly orgs. And we're all still alive, but that kind of paints an interesting picture. Moving on from movie memes to fake quotes. Our friend Benjamin Franklin said once that 1,000 VM conversions start with a simple API call. Of course, that's not quite right, as we'll see. The problem is that the problem is not technical when you're migrating away from VMware. The problem is much more fundamental than that. And it has to do with culture and skills and people. So once you sort out that side of the equation, the actual migrations technically are kind of trivial in a way. So a lot of people who are moving away from VMware have had historically a very, how can I say, they're coming from a corporate background when there's one or two ways of doing things, and now they're coming to this open source world, which was not, something that they wanted to do necessarily. And they have a problem because the philosophy is entirely different. There's like million ways of doing the same thing. It takes a lot of effort to do this kind of major shift in your organization. It requires a lot of skill. Like if you remember what Guido was saying in the morning, that people with a good knowledge of the building blocks of basically the internet and of the services that we are using every day are becoming more and more rare. So you now need to focus on retraining your staff who are not going to be happy about that. You also need to go hiring probably. You also need to get some more certifications. So the journey of 1,000 VM migrations isn't riddled with technical problems. It's riddled with cultural and people problems. And then once you've finally started to tackle all that, then you have this kind of stuff to consider. You can't really say that VMware is necessarily a fully, lock-in situation, because there are ways of getting out of all of these. NSX, vSAN, they don't have necessarily stuff that's impossible to get rid of, but it does take a lot of effort. And yeah, getting out of NSX will be interesting for those organizations that do use it, depending also to the degree that they are using it. vSAN is relatively straightforward, and thank God we have so many replacements for those. So it can be doable. As long as you've managed to sort out the people problem, the rest of the problems are easy to fix. So yeah, it absolutely can be done, and with the right people, with the right help, anybody can get out of VMware. And sometimes, like I say here, on the bottom, you will not find like for like, 100% compatible or, in the same feature set. And sometimes you have to shift your mentality a little bit more or find alternatives. And like our friend Bear Grylls says, it's probably from the army, but improvise, adapt, overcome. I think that will be an important thought to keep in mind for those looking to migrate away from VMware and onto an alternative, be that open source or not. Of course, it's the CloudStack Collaboration Conference, so we're focusing on CloudStack here. So let me quickly go through a sort of matrix that wants to establish some sort of equivalence between the VMware stack and what we can use on the CloudStack side. So we start with the hypervisor, vSphere, which with V2V's help, we can successfully convert into libvirt KVM machines. For VMFS, especially for block storage, which has been a kind of a hot topic, this collaboration, we can use OCFS2. That's an Oracle product, essentially, open source though. GFS2 from Oracle, and there is also an implementation based on cluster DelVM, which in theory gives you the highest performance, but it's a little bit trickier. There will be more things happening about CLVM in the future in the community. In terms of agent and guest integration with the hypervisor, typically you would be using OpenVM tools inside the VMware machines. And for that, for the same roles, we can use a QEMU guest agent in KVM virtual machines. If you're migrating using the built-in CloudStack tooling to KVM, you will have the OpenVM tools automatically removed and QEMU guest agent added into both Linux and Windows guests. For vSAN, we're really spoiled for choice. Really, this is kind of impressive if you think of it. So there's Ceph, there's our friends from List or Store, PowerFlex, and probably there are quite a few that I have not remembered to put here. So I would say from the storage perspective, things are looking really good. The distributed virtual switches in VMware as counterparts in KVM have the Open vSwitch, and of course the good old Linux bridges, which we make use heavily. And still work great with very few problems, very little problems, or no problems at all, depending on what you're trying to do with them. Backup is another hot topic, and people have been lamenting the lack of corporate or enterprise level products like VM and Commvault. However, as you may have heard from various talks, both on stage or off stage, things are changing surely on that front, with Commvault starting now collaboration with US Signal to develop something for CloudStack, and I hear there's some movements inside VM as well with regards to that. So I think by this time next year, things will look hopefully significantly better. Until then, of course, we have enabled in version 4.22 the ability to use incremental volume snapshots. So that can be used as a backup strategy, as well as the native or built-in NAS backup and recovery plugin for KVM. We're hoping that at some point in the future to have also incremental capabilities in that. But yeah, so far it's going to have to be full copies of that. In terms of config management, monitoring, and so on, VMware has had products such as ARIA or vRealize. And again, we are spoiled in this field as well, because we have the likes of Terraform, Ansible, and of course, this being open source and extremely flexible. There's an API there. You can just use shell scripts if you want, so you can hook Cloud Monkey into your scripts and do whatever you need to do. There's integration that can be done with Zabbix, Nagios, and many other products that can do basic HTTP checks and so on and so forth. So now we've addressed the cultural problem, the training problem in our company when dealing with, with migrating from VMware to KVM. We've established, our matrix of products that we can use to replace VMware, and we can come back to our favorite quote here: that 1,000 VM conversions begin with a single import VM API call. The import VM API call is what you would use typically to start in CloudStack migration from VMware. In our experience, having done quite a few of these VM migrations this year, you're looking at 3 stages for this operation, so to say. The first one is the assessment and inventory. So whoever is tasked with this interesting, endeavor needs to first look at what's going on in the source VMware environment, look at the existing VMs, try to classify them by, role, OS specifications, and so on. Try to identify any tricky or unsupported configurations, such as encrypted disks or direct attached storage, and so on. Look for operating systems that are not well supported by Vert V2V, such as BSDs or Solaris. And then once they've finished that, then they need to start building their CloudStack environment to do their own testing, choose how they want to proceed. At first, you may want to use the UI because it's an easy, intuitive, for humans way of doing this operation. And indeed, we've had customers with just a few dozen VMs who chose not to spend time on automating anything and chose to do it by hand, and that's perfectly fine. That's a can get the job done. However, if you have more than a few dozen VMs, it really starts to get old quickly. So you want to automate as much as you can, and you can do that by means of either interacting directly with the API or using CloudMonkey. For me personally, I prefer to use CloudMonkey because I'm not a developer, and it seems to me much more an intuitive tool than that. Of course, on CloudStack side, you need to prepare all the networking and all the storage that will be required to accommodate all the workloads, all the VMs that are coming from the other side, from VMware. So it's the obvious stuff, but of course, it needs to be stated. So I'm not, I don't want to leave out, you should really take, when you're doing this kind of migrations, take snapshots, take backups, try to cover for yourself as much as possible, because if things go wrong, you really want to have something to fall back onto. And stage 3, just do it. I wanted to put here a Shia LaBeouf kind of meme, but I thought maybe keep it simple without too many graphics. The thing is that you really want to start with 1 or 2 pilot migrations, with VMs that are not critical to production, but still have, have a kind of serious footprint that are doing a task or another, and that are used for something to mimic a production workload. Then you convert and import it into CloudStack. You validate that it has been successfully added and started into CloudStack, that it has booted into an operating system without problems, that the networking is working, that the storage is working. And then also you want to look at the performance. The performance ideally should be like for like, roughly. So if you're seeing degraded performance, you need to double check, have the right drivers been activated inside, is the OS type, is the hardware profile of this virtual machine using VirtIO devices as it should, are the VirtIO drivers loaded properly as they should, and so on and so forth. In our experience, Virt V2V has very, very rarely failed to do what I'm saying. So we had actually very few occurrences where we had to intervene manually. Notes and gotchas. So I mentioned that some of the VMs are more difficult to move because they could be of an operating system that is not really well supported by Virt V2V or at all. So I'm looking at BSD, Solaris, Open Solaris, Silumos, this kind of operating systems that are not as popular as they used to be. So you will have to somehow move them through some other means. Many people are using backup and restore via the likes of Clonezilla or Acronis. So that's one way of doing it. And one scenario that one of our customers has come up with, because of the nature of how they were deploying and running their infrastructure, based heavily on infrastructure as a code, is that they have simply chosen to recreate the machines based on changes to their infrastructure and as code manifests. So that was a really quick way of doing things. And if you're this kind of company, yeah, you have this advantage of agility. But if you're running more legacy systems, then as I said, you can look at agent-based backups and restores. Other things that I found tricky when using Virt V2V was the fact that, well, it's not Virt V2V's fault, it's the way operating systems are running nowadays, and that's the fact that both Linux more recently and Windows since forever have named their network interfaces based on not only the MAC address, but also the driver that's powering the network. So in Linux, if you know, we have this now so-called dynamic way of naming the interfaces. They're called predictable interface naming or something like that. So instead of the likes of ETH0, you end up now with an interface name called ENSP0 something, which is nothing but well, unpredictable. So what happened to us is we were moving VMs over from a VMXNet3 driver, right? That's the paravirtualized driver from VMware to Vert.io, and we were seeing like, what the heck is going on? Why is this interface being renamed? Because the MAC address, CloudStack kept it the same as it was in VMware. Well, it's because of that. So there are workarounds for that, and the same thing happens in Windows, which it's no surprise. But as I said, there are workarounds for that as well. So for Linux, for example, one of our customers decided to use systemd or udev configuration to lock the interface name to that MAC address, so it didn't get changed when the kernel noticed, or rather when the systemd noticed a change in the driver. And one easy thing to do to fix this problem is to switch your IP configuration to DHCP. But I have noticed that a lot of VMware customers prefer to use static IP assignments, so switching to DHCP isn't really for everybody. Some have done it, and that worked for them, and you work around the problem with interfaces renaming, as long as they have the same MAC address as in VMware, because then the DHCP server will know to just give you the same IP address, regardless of the driver that's in use. So yeah, that was something that caught us by surprise, but we've worked around it, and it's more than doable. Another gotcha that bit us was the fact that not all Vert V2V apps are equal, in that they're not of the same version. So a lot of people prefer Ubuntu. That's really popular nowadays, and it has been for a while. However, the Vert V2V that they ship is actually quite old, and it's got quite a few problems. So we always recommend customers to use EL9, that's RHEL 9 or clones, such as Oracle Linux or Alma Linux and so on. And of course, there are workarounds for that as well. I think this goes in a way back to what Wido was saying, that you need to learn Linux to do all this stuff. Because this is, what you're seeing here, this is nothing extraordinary, but you really need to know, to have worked with Linux for a while and built up that expertise, which you may not have if you're coming from VMware. So that's where, training comes in, and skills and so on. So yeah, the problem is not just finding these solutions on a blog or a slide. Getting back to this particular issue, how to sort it? Well, first of all, is install Vert V2V from source. Just configure make install if that sounds familiar, or find some custom repository that has a newer version. I could not find it. Or install another cluster with EL9, which has the right Vert V2V version. And something a customer did and really surprised me, and again, takes me back to what I've said previously. Once you get into this game of working with open source, it's the people. If you have the right people, then you won't have a problem, and you'll sort out all your issues. So what have they done? They went with Ubuntu because they liked it, or whatever that was their default thing. And who can tell me what this does, roughly? Tell me. Okay, no, it did not copy the binary itself. So, exactly. So they've replaced the Vert V2V binary with a shell script, and then they're sending the command, they're executing Vert V2V on that remote EL9 host. It's the right Vert V2V, which has the storage is mounted in all the expected places. So that's a step you need to be careful. And then it sends over all the parameters that were sent to the local Vert V2V. And because the remote host has all the NFS, primary storages and all that that's needed to work, yeah, that worked just fine. And not only has that worked just fine, these servers were not part of the CloudStack installation. They weren't hypervisors that were in use, that were loaded. So following this kind of hack, you can just use any random server you have in your data center and get the job done. I wish I could take credit for this, but again, it just goes to show if you have the good people, 5 minutes, all right. If you have good people in your company, hang on to them because that's all you need to sort out any problems. So another thing that I want to say is that perhaps it's obvious, but you can run parallel conversions. So very anecdotally, a kind of largish VM, let's say a few hundred gigabytes on reasonably fast hardware could be converted in about 3 hours. That's 3 hours of downtime, unfortunately, so you have to stop your VMs, at least the Windows VMs. So if you run about 5 concurrent migrations and you have 5 hypervisors or such hosts that you can send Vert V2V commands to, then you could be looking at migrating about 200 VMs in 24 hours. So if you do the math, 1,000 VMs, it's not a lot of effort if you've sorted out your cultural and process and people's problems. So I guess I finished my slides here, and big credits to, of course, the Apache Software Foundation, and to this guy, Richard W. Jones from Red Hat. I think he's the main developer of Vert V2V. I think the whole planet owes him quite a lot in these times with Broadcom doing what they're doing. So yeah, we should maybe do I'm not sure what we should be doing to help him, but thank you if you're watching. Of course, Shape Blue for paying us for the time to do all this research, and Broadcom, because otherwise would be just fine at home, minding our own lives. And that is it. Questions? Thank you.